Very good morning to all. Welcome back to CMOS Design. This is lecture number 20. Last two classes, right, we have been discussing the frequency response of amplifiers, and for that we have been building, right, the fundamentals. So last class, what we discussed? Anyone? So we have been discussing, right, finding the poles, okay, by inspection, and in order to give, okay, and we discussed that Miller effect. So now I want to continue the same. So for today's class, actually, I want to give four more examples, okay, to build the fundamentals of a frequency response. Fundamentals, okay, to compute the frequency response. Take the first example. In that, sorry,
Screen
screen.
present ಆಗಲ್ಲ sir.
Sir,
Screen present ಆಗಲ್ಲ sir.
you didn't present the screen, sir.
Let me rejoin. Actually, I shared my screen. You must grant permission in order to share screen. At
நவீன்ட்டு நினைக்கிறேன் சார்.
Naveen,
Sir,
yeah. Now is it visible?
Yes,
yes sir.
Okay. So actually, we have been discussing, right, the fundamentals, okay, to compute a frequency response, and you know how to find, okay, the poles, okay, by inspection this time, just by seeing the circuit diagram. So yesterday, I hope around three problems, three examples we solved, right? So today I want to add four more examples. So before adding this example, I want to teach one more thing. Okay, so totally how many capacitors, okay, are present inside a MOSFET? Take NMOS, right? NMOS. How many capacitors are present, okay, inside this NMOS? Any idea? That already we discussed in unit 1. Take this is my NMOS. Take this is my source, drain, gate, right? So, you know, between gate to source, என்ன இருக்கும்? ஒரு drain. I hope so you can remember this structure. Then between gate to drain, one capacitance. Okay. Is there any other capacitance? Actually, totally four terminals, right? Here we are having one, you know, bulk. That bulk is connected to ground, right? Okay. So this source to bulk, one capacitor, that is called CSB. This drain to bulk, one capacitor. So totally it is very important. Four capacitors, right? Caps means capacitor, no? So four caps, okay, are associated, okay, with each or with single MOSFET.
Sir,
Any doubt? Yeah.
gate to bulk ஒரு capacitor இருக்கும்.
Gate to bulk.
Yes sir.
கேட்டுக்கும் பல்க்குக்கும் நடுவுல இன்சுலேஷன் மெட்டீரியல் இருக்கும் இல்லையா? திஸ் ஆல்ரெடி வி டிஸ்கஸ்டு. இதே கொஸ்டின் தான் அந்த நான் தரப்ப கேட்டேன். It is not possible to form a capacitor between gate and bulk.
Sir, for between gate and insulator ஒரு கெபாசிட்டர் insulator and bulk ஒரு கெபாசிட்டர் இருக்கும்னு சொல்லிட்டு நம்ம பார்த்தோம்ல சார் 1/C GP equal to 1/C1 plus 1.
Between that gate and bulk, right? And the insulating material ரெண்டா பிரிச்சுட்டு parallel போட்டோம், right?
Yes sir, yes sir.
But that capacitor is, very small value. Just, if you study the physics of MOSFET, right, that capacitor you want to calculate, you want to consider. But coming to frequency response, totally these four, இதுலயுமே இந்த பார்த்தீங்கன்னா இந்த it won't give much impact. The source to bulk, drain to bulk. These two plays a vital role, okay, in frequency response. So again, already ஒரு insulating நடுவில் வச்சுக்கிட்டு, okay, so it makes, okay, the things complicate, okay, so no need to consider that capacitor, okay, between that gate and the bulk.
Okay sir.
So totally in general, okay, take any textbook, they will speak about these four capacitors. So
Okay sir.
according to Rasavi, these four capacitors, okay, are associated with each and every MOSFET, okay. And the high frequency response, sorry, the high frequency model, the low frequency model that right, for small signal model, nothing but low frequency model that already we studied. This is, single, voltage controlled current source. This value is given by VGS, and VGS is the input voltage plus minus. This is my gate, and this is my drain, and this is my source, right? So now this is my low frequency model. Now coming to high frequency model, you want to consider all the capacitors. So how will you connect all these capacitors? First take between gate to source this capacitor. Take, this is 1, 2, 3, 4. Connect all the capacitors with a different color. So between gate to source, okay, this one, right? So between gate to source, I am having CGS. Between gate to drain, okay, between gate to drain, CGD. Then between source to bulk, bulk is connected to ground, okay. Actually this is my source, right? So now do one thing, now connect this one to ground. This is your CSP, and this is your drain. Here we will measure the output, right? And this is my CDB, okay. Now it becomes high frequency model. This already we discussed even in EC1, okay, fourth unit. So for low frequency model, we won't consider capacitor, right? Why? Because the impedance offered by the capacitor 1 divided by C omega, where omega equal to 2 pi Fc. At low frequency means at F equal to 0, this Xc becomes infinite. Infinite means open circuit, right? So at low frequency, actually all the capacitors are open. But at high frequencies, okay, this you want to consider, okay, this capacitor. You know the reason why. Okay, just apply this logic at high frequency. It will give the impact of short circuit. So some finite impedance, right? This capacitance will give ideally short circuit, but practically some finite impedance. So we want to consider, okay, all the capacitors associated with this MOSFET, okay, for frequency response. So any doubt in this high frequency model? And similarly, one more point I wanted to add to Karthikeyan's questions. In small signal model, we won't consider, that bulk and all. So again, it is it gives, okay. Again, we are increasing the complexity if we will include that What is that? The capacitance between gate and bulk, and that value is very low. Okay, when compare even the CSB and the CDB, this values are actually very low. When compared to that capacitance between gate and bulk, that is very low when compared to the CSP and the CDP. Even the CSP and the CDP is very low when compared to CGD and the CGS, and this CGS actually is very low when compared to CGD. This also we studied in EC1. Okay, so for frequency response, consider these four capacitors alone. Okay, we will play with these four capacitors. So far, any doubt?
No doubt, sir.
Now go with example 1. Take this example. Common source. Actually, here I am giving some input, and this is my output. Sorry, common source. Source is grounded, and this is my V. Okay, this is some stage, and previous take this stage n. So actually, before that we may have stage n minus 1, right? Previous stage. This previous stage, it may have some output resistance, right? So that resistance actually you want to connect. So here, this is the output resistance of previous stage. Time being, I want to take it as Vi. So this Vi, it is the output resistance of previous stage. So it becomes the input resistance of this stage. Just for our understanding. Okay. Now, how many capacitors? Find all the capacitors. Why we are doing this? As I told you earlier, just we are building the fundamentals, right? So step by step we will do. So first we will find all the capacitors. Okay. So let me go with this time black color. Just to draw all the capacitors, right? You know, for single MOSFET, we are having 4 capacitors, right? So this is my C between gate to source. This is between drain to source. Here between source to
Gate
bulb.
to drain, sir.
Thank you, ma'am. And here between drain to bulb. Okay, totally 4 capacitors. We want to think about 2 things, ma'am. One is called elimination. One is called elimination, or nothing but is it possible to remove any capacitors? We want to think about. Then we want to think about merge. Is it possible to merge any 2 capacitors or any 3 capacitors? We want to think about these 2. Now coming to CSB. Think about this guy CSB. Where is it connected? See, this is my ground, right? Ground. This is also ground. So where CSB is connected? CSB connected between ground and ground. So we can eliminate CSB. So CSB eliminated. Okay. Before that, before remove or merge, you want to do one thing. Give proper AC ground connection. See, this VDD, it must be connected to AC ground, right? Actually, the exact symbol for AC ground is this one. This is symbol for AC ground. Actually, this is my DC ground. Okay, so this VDD must be connected to AC ground. Okay, so we can remove CSP. So remove is possible. Is it possible to totally how many capacitors? So first point, one capacitor is removed. Is there any other? CGS எங்க connect ஆயிருக்கு between gate to ground. CGD between gate to drain. Then what about the CDB? அது between drain to gate. Okay. CDB drain to gate. Okay. So one capacitor is removed. Remaining எத்தனை capacitor? 3 capacitor. Is it possible to merge any capacitor? Here it is not possible because this is gate to source, this is drain to bulk, this is gate to drain. So no merging possible here. That we will discuss in the next example. Out of these three, so totally 3 capacitor are there. Out of these three, who will experience Miller capacitance? Is there any Miller capacitance? Out of these three, who will experience Miller capacitance?
CGD.
So CGD, okay, experiences Miller capacitance. Just I'm giving the hint, okay, to develop the frequency response. Why I am doing all these things that you can understand after some time. Okay, so this is my first example. Take this example. Simply I have taken one common source. அதுல எத்தனை கெப்பாசிட்டர் இருக்குன்னு கண்டுபிடிச்சிருக்கிறேன். எதுக்கு? To develop or to find the frequency response. That we will do it later. We will go step by step as per Rasai. Now I want to go with example 2. Okay, this time slightly I want to increase the complexity. For that I want to take this guy base code. நல்ல spaces வரைஞ்சிக்க. I will let you know why. Take this is my M1, right? There I want to give Vn. நல்ல spaces வரைஞ்சிக்க. இந்த மாதிரி நிறைய space இருக்கு. Take this is my PMOS, right? It is giving current from VT. This is my VB. Here I am measuring output. Here I am giving input. Okay. So now find all the capacitors. The question is find all the capacitors. Very simple. This is just for our understanding. இந்த மாதிரிலாம் எக்ஸாம்பிள் கேட்க மாட்டாங்க. Find all the capacitors. This is just we are building, right? We have been building the fundamentals. Okay. Now take this is M2. First step என்ன சொல்லி இருக்கிறேன்? Step 1, proper AC ground. Proper AC ground in the sense, see, this time this biasing voltage must be connected to ground. Okay, this VDD must be connected to ground. Okay, my AC ground that you can do by yourself, just for our understanding. Okay, it is connected to ground, that we know. So first step is over. Step 2, now draw all the plated capacitors. This time I am choosing red color. Okay, for what is this? M1. So this is gate to source of 1. This is capacitor source to bulk of 1. This is capacitor between the drain to gate of 1. Okay, and here one capacitor between gate, sorry, this is drain, right? So drain to bulk of 1. Okay, so 4 capacitors remaining. Now draw the 4 capacitors, okay, associated with the M2. This time I have chosen என்ன கலர் ப்ளூ கலரா கலர்ல ரொம்ப வீக் so please I have chosen blue color. So let me drop all the capacitors. This capacitor between source to bulk of 2, and here between source, this drain, right? Actually this is PMOS, so let me correct this. This is my source, this is my drain, right? Since it is PMOS, so this is my drain to bulk, and this is my source to bulk of 2, and here one capacitor, and this is called gate to source of 2, and here gate to drain of 2. Hope this clear, right? First listen me properly, then I will give you time to play. Second step என்ன சொல்லியிருக்கேன்? Is it possible to remove? Second step you want to look for elimination. Is there any possibility? You guys now please reply. M1. What about CSB1? Where it is connected?
Ground to ground.
So I can eliminate, right? Add a color for it. Okay. Is there any other capacitors? What about
CSB2.
CSB2? That is also ground to ground. What about GS2? Ground to ground. So CGS2. 3 capacitors removed. Okay, so remaining எத்தனை capacitor? Totally 8. 8 minus 3, 5. Okay. So second step, step 3. So 3 capacitors removed. Step 3. Is it possible to merge? Is it possible to merge?
CDB2 and CGD2.
CDB2. Okay. Let me take this, right? CDB2. Where it is connected? CDB2.
Drain to ground.
Drain to ground. What about CG2? CG2, Ama? What you told?
Yes, sir.
This one, right? Okay. So ரெண்டுமே நான் பிங்க் கலர்ல வச்சிருக்கேன் பாரு, just for your understanding. அப்ப CGD2 எங்க இருக்குன்னு பார்த்தேன்னா between drain, right? Drain எழுத போறோம் பாரு. Okay. So you can merge these two, right? Is there any other? Very good, very good, good. So CDB ones also, right? Where it is connected between drain to. Okay, so merging la பாத்தீங்கன்னா இது இங்க எழுதிக்கப்பா 3 capacitor removed. Okay, coming to merge, அப்ப you can merge parallel CDB2 எல்லாமே எப்படி கனெக்ட் ஆயிருக்கு இப்ப எல்லாமே drain to ground, அப்ப எல்லாமே parallel. So parallel means you want to add, right? So CDB2 plus, hope I am clear. Is there any other possibility? அப்ப இப்ப நான் 3 மெர்ஜ் பண்ணிட்டேன். இந்த 3 கெபாசிட்டர் இப்ப என்ன ஆகும்? சிங்கிள் கெபாசிட்டரா இருக்கும். அப்ப டோட்டலி how many capacitors now? 8 minus 3, 5. Okay, 5ல 3 கெபாசிட்டர் பட் இந்த 3 கெப்பாசிட்டர் சிங்கிள் கெப்பாசிட்டரா இருக்கும். ஸோ டோட்டலி ஐ எம் எண்டிங் வித் 3 கெப்பாசிட்டர்ஸ் ஒன்லி. ஓகே, யாரெல்லாம் அந்த 3 கெப்பாசிட்டர்ஸ்? இது ஒரு காம்பினேஷன், ரைட்? நவ் செகண்ட் யாருமா? சி, யூசிங் திஸ் டைம் கிரீன் கலர். CGS1, this is my second one, right? இது செகண்ட்னு மார்க் பண்றேன். அப்புறம் CGD1, இது வந்து தேர்ட், ரைட்? CGD1. அப்போ 3 கெப்பாசிட்டர். இது ஒரு காம்பினேஷன்ல ஒரு கெப்பாசிட்டர். This is my 2, this is my 3. Out of these 3, now who will experience? That is my step 4. Who will experience Miller effect? CGD1, right? Experiences Miller effect. Step புரியுதாமா? Step 1, யாரெல்லாம் who are all will be connected to ground அப்படிங்கறத பார்க்கணும். Step 2, you want to drop all the capacitors. அதுல first step remove. Is there any possibility to remove? Second step merge. ரெண்டு கீவேர்ட் நான் வச்சுக்கோ, remove, merge. அது முடிச்சதுக்கு அப்புறம் who will experiences Miller effect. So this is the flow. Now you please do this example by yourself and let me know how many capacitors are there, யாரெல்லாம் வந்து ரிமூவ் பண்ணலாம், யாரெல்லாம் மெர்ஜ் பண்ணலாம் அப்படிங்கிறத you want to let me know. Now take this example. போன எக்ஸாம்பிள் என்ன எடுத்தேன்? கேஸ் கோடு வித் PMOS. ஓகே, திஸ் டைம் ஒன்று பண்ணலாம். அபோ வந்துட்டு இன்புட் கொடுக்குறேன். திஸ் டைம் ஓகே, நல்லா ஸ்பேசியஸாக வரைஞ்சிக்க, அப்போ தான் கெப்பாசிட்டிலாம் ட்ராப் பண்ண முடியும். இங்கே விபி வச்சுக்கலாம். This time I have gone with 2. Let me call this is M1, this is M2, and as usual here we are measuring the output voltage, and this is my VD. Yeah, you practice by yourself all the 4 steps, right? Step 1, proper ground connection. அதுக்கப்புறம் drop all the capacitors. Step 2, remove. Step 3, merge. Step 4, who will experience Miller effect. So you do by yourself, take your own time just to practice. In case of any doubt, please okay, no, I don't want to try it. I am expecting the answer from you people.
மேல இருக்கிறது CMOS தானே சார்?
மேல இருக்கிறது
CMOS தானே சார்?
CMOS இந்த எக்ஸாம்ல
M1 வந்து இல்ல சார், இந்த எக்ஸாம்பிள்ல M1 அந்த MOSFET 1 வந்து CMOS தானே சார்?
MOSFET 1 PMOSங்கறியா? ஏன் PMOS இருக்கணும்? நான் இன்புட் இங்க கொடுக்குறேன்.
இல்ல,
நான் வந்துட்டு இது ஒரு NMOS, அதுல என்ன பண்றேன், இன்னொரு NMOS, it is acting as a current source. புரியுதா? இது ஆல்ரெடி we discussed. கேஸ் கோட் எடுத்துக்கமா. இது நீ காமன் சோர்ஸ் ஸ்டேஜ்னு நினைக்கிறியா? இது ஜஸ்ட் ஃபார் அவர் அண்டர்ஸ்டாண்டிங். திஸ் இஸ் ஒன் கேஸ் கோட் கான்ஃபிகரேஷன். ஓகே, நான் என்னன்னா ஜஸ்ட் ஃபார் பிராக்டிஸ் ஐ ஹவ் டேக்கன் திஸ். ஓகே ஓகே okay. Step 1, what is this? So this must be connected to ground this time, and this VDD must be connected to ground. Step 2, drop all the capacitors. This is my gate 1, gate 2, right? Gate 2, source 2. What is this? Source, you do by yourself, no? Source 2 bulk 2. drain to bulk to gate to drain to. Capacitance. This time this is source drain drive. So drain to bulk 1. I dropped all the 8 capacitors. First
Sir.
step. தப்பு பண்ணிருக்கேனா சொல்லு
இல்ல சார் ஒரு டவுட் சார்.
சொல்ற
சார் நம்ம மேல M1 வந்துட்டு M1க்கு கீழே வந்து சோர்ஸ் டெர்மினல் சார், M2க்கு இங்க ட்ரெயின் டெர்மினல் சார். ஸோ நம்ம வந்துட்டு இந்த இடத்துல வந்துட்டு இது ஒரு சிங்கிள் நோடா கன்சிடர் பண்ணுமா இல்ல சோர்ஸ் ட்ரெயின்னு கன்சிடர் பண்ணுமா சார்?
எது கேக்குற?
இங்க நமக்கு சார் அததான் சார்.
ரிப்பீட் பண்ணு.
இந்த இடத்துல பார்த்தோம்னா காமனா வந்து CSB1, CDB2 அண்ட் CGS1 இது மூணும் காமனா இந்த நோட்ல இருக்கு சார். இந்த நோட் டு கிரவுண்ட்
இத வந்து என்ன பண்ணனும்னா this one you want to treat as a separate capacitor, separate MOSFET. இது ஒரு separate MOSFET. Okay, you want to drop all the capacitors associated with this M1 and M2. Okay, இந்த இடத்துல நோடு நான் பேசவே இல்லை. நான் என்ன பேசுறேன், சிங்கிள் கெப்பாசிட்டர் ஒரு சிங்கிள் MOSFET, அதுக்கு 4 கெப்பாசிட்டர். அப்ப எத்தனை MOSFET இருக்கோ that times 4 times of that MOSFET, அது டோட்டல் கெப்பாசிட்டர். அதுல எத்தனை மெர்ஜ் எத்தனை ரிமூவ். ஓகே, திஸ் இஸ் த ப்ரொசீஜர். இந்த இடத்துல நோடு பத்தி கன்ஃபியூஸ் பண்ணிக்காது. சரியா?
ஓகே சார்.
லேட்டர் we will play with high frequency மாடல். இன்னும் நம்ம தெளிவா ஸ்மால் சிக்னல் மாடல் போடுறப்ப உனக்கு அந்த கான்செப்ட் புரிய வந்துடும். சரியா? slowly we will build. ஓகே, ஸோ now 8 கெப்பாசிட்டர் வரைஞ்சிட்டேன். யாரெல்லாம் ரிமூவ் பண்ணலாம்? எனி ஐடியா? CSB2 ground to ground, CDB1 ground to ground, CGS2 ground to ground. So here also 3 capacitors removed. Correct, Amma? Is there any other capacitors? 3 caps removed. Okay. யாரெல்லாம் merge பண்ணலாம் this time? I'm using pink color. Is it drain to? Actually, this is, both are same node this time, right? Same node actually. Okay. So here to ground. This is also here to ground. Then I can merge only these two, correct? And here this one. I have used pink color, right? எப்போ மாத்தினேன்? இந்த பிங்க் கலர்ல ரவுண்ட் பண்ணிருக்கிறதெல்லாம் இது பண்ணலாமா? என்ன பண்ணலாம்? மெர்ஜ் பண்ணலாமா? யாரெல்லாம்? CSB1, CDB2, CGD2. ஓகே, அப்ப 5 கெப்பாசிட்டர் போச்சா? இந்த 6 கெப்பாசிட்டர் போச்சு. மிச்சம் 2 பேர். சரியா? மிச்சம் 2 பேர் who will experience Miller effect out of these two? இந்த 2 கலரை எப்படி பிளாக்ல மார்க் பண்ணிட்டா? Now out of these two, sorry, C experiences Miller effect. Hope so you got the idea, right? My final example is example 3. This time I want to play with common gate. Example 3 புரிஞ்சாமா? எல்லா கெப்பாசிட்டரையும் பாரு மார்க் பண்ணியிருப்பேன் in such a way. இந்த greenல மார்க் பண்ணதெல்லாம் removed, pinkல மார்க் பண்ணதெல்லாம் merge, அதுக்கப்புறம் black இருக்கிறது remaining 2. அதுல who will experience Miller effect? Okay, so this is the way. Now let me go with my favorite common gate. Gate is common, so it must be connected to. Here I am giving input voltage V in, and here we will measure the. Here one BT is there. Try to find out the BT. Okay. நான் ஸ்பேசிஸா வரைஞ்சிக்க ஒன்னு சொல்லிட்டு நானே கம்மியா வரைஞ்சிருக்கேன். பட் எனியோ at the very first step, ground connection, right? Ground. The biasing voltage must be connected to ground. This VDD must be connected to ground. Then you want to drop all the capacitors. Then a gate to source, right? This is my CGS. அப்புறம் இங்க எனக்கு gate to drain CGD. அதுக்கப்புறம் drain to bulk, and this is my source to bulk. Who can be removed? ஏன்னா அது எங்க இருக்கு? Drain to bulk, right? So this is not the correct one. Drain இங்க தானே இருக்கு. This is my drain to bulk. So this time, is there any elimination?
No, sir.
No elimination. Very good. Merge. யாரெல்லாம் merge பண்ணலாம்? Pink color. CGS CSB, right? இது source to ground, இதுவும் source to ground. So first merge வந்து பார்த்தீங்கன்னா CSB CGS. அதுக்கப்புறம் வேற யாரை merge பண்ணலாம்? Drain to ground. So second, I am writing it as AB. So this time two merges are possible. CGD. Okay, I touched all the capacitors, right, by using pink and green colors. So this is the way to practice. Now, up in the two capacitor, is there any Miller capacitor out of these two? Anyone experiences Miller capacitor? That's the beauty. No Miller, no elimination in common gate. No Miller effect. Hope so. I have given some insights, right, to develop, to build. Okay, so far any doubt in these four examples? ஏதாவது புரியாம இருக்கா? பிளைண்டா இருக்கும், that I can understand. ஏன்டா அதை நடத்திட்டு இருக்கேன்னு உனக்கு புரியாம இருக்கலாம். That you can understand after some time. Okay, just as I told, I am building the fundamental. Okay, time என்னமா? 10:22, 10:30, right? Yeah. Then let me start with this guy. Who is this guy? Common source, right? Yeah. Now with this fundamental, straight away I want to jump into common source. So let me put the heading frequency response of common source. As I told earlier, now we are going to study the frequency response of common source, common gate, common drain. அதுக்கப்புறம் case code, then finally differential pair. இந்த 5 பேர் நம்ம படிச்சோம்னா செகண்ட் யூனிட்ல ஆம்பிளிஃபையர்ங்க டாபிக்ல படிச்சோம். அந்த 5 பேரோட ஃப்ரீக்வன்சி படிக்க போறோம், அவ்வளவுதான். So for that, hope so this much fundamental is enough, right? Now frequency response of common source stage. Okay, இப்போ இது I hope so it will be very easy for you. இப்போ ஒரு common source stage நமக்கு தெரியும் எப்படி வரையணும்னு, right? Here we will give the input Vi. This source is common. Output we will measure it from, right? Collector V out. This is my VDD. This is my RD. But as I told earlier, this is my stage n. Just to consider if this is my stage n, and you want to consider, okay, the stage n minus 1, okay, stage n minus 1 output resistance that will act as the input resistance of this stage. So let me add that also here. That is my RG, since it is connected with this gate. Okay, slowly I am modifying, okay, the common source stage for based on frequency response. Okay, now this is my complete circuit diagram. Now we can play with this. I want to compute okay, the frequency response. The very first step, as usual, you want to first, actually I want to give separate procedure, later I will give to compute frequency response. Okay, first நம்ம இதை play பண்ணி முடிச்சிடலாம். Then from this we will build the procedure. Okay, very first step, draw the circuit diagram. Actually இதான் circuit diagram, complete circuit diagram வரைஞ்சாச்சு. Second step, you want to drop all the capacitors. என்னென்ன capacitor? This time you know this is my gate to source. This is my source to bulk. This is my gate to drain. This is my drain to bulk. Any elimination? Next step, you want to look for elimination. Any elimination? Source to source already connected to ground. So ground to ground, CSP is connected. One elimination. Okay. Remaining three. Remaining three is there. அதுக்கப்புறம் என்ன பார்க்கணும்? Any possible for merge? இங்கே மெர்ஜ்லாம் இருக்காது. ஏன்னா சின்ஸ் ஒரே ஒரு கெப்பாசிட்டர் தான், சாரி ஒரே ஒருத்தர் தான் மாஸ்பெட். அதுல இங்க இந்த காமன் சோர்ஸ்ல மெர்ஜ் இருக்காது, வேற காமன் கேட்ல மெர்ஜ் இருக்கும். that already we discussed. Who will experience a Miller effect? This guy, right? Experiences Miller effect. Now can you sketch the high frequency model? Okay, just listen me carefully. In order to sketch high frequency model, as usual, I want to start from input side. So input, I am having this guy VI plus minus, it is AC signal. Then I am having this RG. Okay, RG. Then how to actually this high frequency model of this MOSFET, right? So straight away play with that. So this is my gate, since this is common source. So source is connected to ground, and output, this is my drain. First என்ன இருக்கும் actually gate to source, right? Gate to source actually open circuit, but here first this is MOSFET, it is a voltage controlled current source. So it is GMVGS, where VGS, okay, is the voltage across, okay, between voltage between gate to source. And here if you want, you can include this guy RO. Okay, if you want, you can include. Okay, this is my low frequency model. For the high frequency model, you want to consider all the capacitor. First capacitor, this one take it as 1 between gate to drain. So I'm having one capacitor CGD, gate to drain. Upon gate to source, I'm having one capacitor. This is my source terminal that you know CGS. Okay, then drain to bulk. Bulk is actually connected to ground. This is my CDB. Okay, here we are measuring the output. What happened to CSB? Since source is connected to ground, actually we removed the CSB, so no need to include. So this is the high frequency model. What happened to this RD? We removed this, we replaced this transistor by its high frequency model, and I am remaining with this guy RD. Okay, always the best practice, assume lambda equal to 0 in order to avoid the complexity. So I don't want to include this guy. Okay, now this is my high frequency model. Any doubt in sketching this high frequency model? Step by step, you please do by yourself, nothing new to you. Okay, if you will sketch it one time, then you will get the clarity. Is doubt ruga? Okay, actually 4 capacitor or no, or capacitor removed that, you know. So now, is it possible to find the next step enna pannanum appadina, you know, out of these three, who will experience this Miller effect that, you know, this guy experiences Miller effect. Okay, Miller effect, you know, as per Miller theorem, this capacitor, okay, it is common between input and output. So these can be replaced by two capacitors, right? So here I am including this guy Miller effect. Okay. VGS plus minus CGS RG. Later I will explain. First I will sketch this GUVGS. Okay. See, now this capacitance CGD, it is common between input and output. It can be replaced by two capacitor, one at input side, another one at output side. Let me call this one as C1. I'm using some other color, C1. Let me call this one as C2. And you know the formula for C1, right? Where, what is the formula for C1? Miller, C1 is nothing but this CGS is multiplied by a factor 1 minus voltage gain. The voltage gain for this common source is GMRD that you know. Similarly, C2, CGS multiplication, right? CGS, it is this time 1 minus 1 over AV, right? So 1 plus GM, 1 over GMRD. Okay. So what is the next step? Next, is it possible for merge? These two capacitors can be merged. These two capacitors can be merged. Okay, so I am redrawing it here. Vi plus minus only one capacitor at input side. This one I call it as CGS plus C1, where C1 you know the formula. Coming to output side, this one I can merge it as, and this is my RT. This one again was it as C2 plus CDB. This is my RT. This is GM, which is okay. Now we can find the poles, okay, by inspection. Finding the poles by inspection. How many poles? See, this is one node and this is another node. Okay, let me call it as this one is omega p in input side frequency. So it is 1 over, okay, R C, R is RG, C is CGS plus C1. Let me call the next one as omega P out. It is 1 over R is RD, C is C2 plus D. Okay. So after finding the poles by inspection, and you know how to write the transfer function or gain, right? It is this minus GMRD over 1 plus S by omega P1 times 1 plus S by omega P2. Replace omega P1 and omega P2, but I have taken as omega P in and P out, right? So let me call it as omega P in and omega P out. So this one you will get minus GMRD over 1 plus S times RG times CGS plus C1. Okay, then 1 plus S times RD C2 plus CDB. Such a big derivation, right? Such a big expression. But the beauty, we are writing it in one line, right? That's the beauty. And you know how to find after that? After finding a gain, the frequency plot, you know how to, even without calculating the magnitude, okay, without calculating the magnitude for each and every number, நமக்கு இந்த டைம் யார் ஹெல்ப் பண்ணுவா? Our bode omega radian per second. This is gain in magnitude. It starts from minus GMRT. Guys, are you with me? நான் மட்டும் பேசிட்டு இருக்கேனா?
Sir, listening.
Let me assume omega P in is less than omega P2. Not very less than. So first I am feeling omega P in. So minus 20 dP per decade. Next I am feeling omega P out. Another minus 20 dP per decade. See, our common source, our frequency response, and our derivation may illama, but we have written all the final expression, and finally we sketch that. We have drawn the frequency response plot. So that is the beauty of this analysis. I hope so you enjoyed this and enjoyed the flow. Rasavita நான் நிறைய என்ஜாய் பண்ணேன். I enjoyed a lot, okay, from Rasavi's book. But இந்த கான்செப்ட் என்னன்னு தெரியல, ரொம்ப ஹார்ட்டை டச் பண்ணுச்சு, ஏன்னு புரியல.
சார் நம்ம ஃப்ரீக்வன்சி ரெஸ்பான்ஸுக்கு ஈஸி ஒன்லேயே வந்து அந்த மில்லர் கெப்பாசிட்டன்ஸ்க்கே அவ்வளோ டிரைவ் பண்ணியிருக்கோம் சார்.
நிறைய டெரைவ் பண்ணோம். கரெக்ட்
சார்.
அவ்வளோ டெரைவ் பண்ணிட்டு, ஆனா இங்க அவ்வளோ டெரைவ் பண்ணி அந்த ஃபைனல் எக்ஸ்பிரஷனை எப்படி உனக்கு சொல்லியிருக்க மாட்டேன்னு நம்புறேன். ஆனா இந்த டைம் வந்துட்டு அதை டெரைவ் பண்ணாமலே ஃபைனல் எக்ஸ்பிரஷன் எப்படி எழுதுறதுன்னு செகண்ட் இயர் சொல்லி கொடுத்தேன். அது பிகாஸ் ஆஃப் திஸ் எஃபெக்ட் தான், இந்த இதனாலதான். அது அந்த லீஸ் ஒன்று ரிலேட் பண்ணி பாக்குறப்ப ரெண்டுமே கரெக்டா மேட்ச் ஆச்சு. தட் மே பி த ரீசன். அது எனக்கு அப்ப தெரியல, உனக்கு நடத்தினப்ப எனக்கு அந்த இந்த அளவுக்கு தெரியாது, டு பி ஹானஸ்ட். ஸோ அதுதான் கடவுள் எப்பவுமே நம்ம ஒன்று தேடணும்னா அதுக்கானது கரெக்டாக கொடுப்பாரு அப்படிங்கிறதுக்கு இதுக்கு ஒரு எக்ஸாம்பிள் நான் நம்புறேன். ஒரு தேடல் கரெக்டான வேலை இருக்கணும். நான் ஒன்றும் பெருசா ஒன்றும் தேடிடல, பட் என்னையோ நான் தேட வேண்டியது என்ன அதிகமா இருக்கு. ஐ நோ ஐ எம் லேகிங், பட் இருந்தாலும் அதில் ஒரு சின்ன பார்ட்டாக இதை எடுத்துக்கிறேன். ஸோ தட்ஸ் இட் ஃபார் டுடேஸ் கிளாஸ். ஸோ எனி டவுட்? ஸோ ஒரு காமன் சோர்ஸ் ஆரம்பித்தோம். ஓகே, ஐ ஹோப் ஸோ யூ என்ஜாய்ட் திஸ். அண்ட் tomorrow we will discuss about common gate and drain source follower one by one. Okay, once if you know all these fundamentals, then I hope so you can do by yourself hereafter. But anyway, ஒரு 1 or 2 கிளாஸ்ல சீக்வன்ஸ் முடிச்சிடலாம். இந்த வீக் சாட்டர்டே சண்டே ஃப்ரீயா இருந்தா சொல்லுமா, தென் வி வில் பிளான். மார்க் இன்டர்வியூ இருக்குன்னு நினைக்கிறேன். ஜஸ்ட் ஸ்டடி ஃபார் தட். மை பெஸ்ட் விஷஸ் ஃபார் யுவர் பிளேஸ்மெண்ட் ப்ரிப்பரேஷன் ஒன்ஸ் அகேன். ஸோ வித் திஸ் let me stop here. The time is 10:40 ஆகிறேங்கப்பா. எனக்கு அடுத்த ஒரு ஈஸி டூ. Thank you. Thanks for your attention. Let me stop the recording.